Good morning, class. Today we're going to pick up again with some logarithmic functions today. First, we're going to talk about the domain of each of these functions. All right, now do remember that the kind of parent function of a logarithmic function looks something like this. All right, so then we have to factor in transformations and everything. All right, so here, all right, we've got a simple shift to the right 2. All right, so the domain here, all right, instead of being from 0 to infinity, it's going to be 2 to infinity. All right, now here, all right, you can kind of think of this more as negative x plus 2. All right, so we know that there's going to be a shift, and we know that it's going to be reflected about the y-axis, so it's going to be flipped over here. And it's always nice to kind of take a look at this. Always nice to take a look at this. All right, so obviously it's been shifted to, it's been reflected about the y-axis. Then it's been shifted to the right too. I know that you would think that normally this is to the left too, but because of this negative out here, it actually kind of messes things up a little bit. So it's always good to be careful there. When in doubt, just plug a couple of x values in to get some points, and then that should, kind of definitively tell you which way we're going here. All right, ln of x squared. Now, remember, we aren't allowed to plug in negative numbers into logarithmic functions, but when you square something, it actually makes it positive when you square a negative number. All right. However, we aren't allowed to plug in 0 either. So the domain here, I guess I should actually put this domain here, right? From negative infinity to 2. All right, the domain here is actually going to be from negative infinity to 0, union 0 to infinity. Right, because all the negatives are fine, because when you square them, it becomes positive. But you still, when you square 0, you still get 0. So that doesn't really help anything at all. Here, of course, we just take this and move it to the left 3. So we have from negative 3 to infinity. All right, students participating in a psychology experiment attended several lectures on a subject and were given an exam. They were given an exam every month for a year. After the exam, the students were retested to see how much of the material they remembered. The average scores for the group are given by the human memory model. F of t is equal to 75 minus 6 ln of t plus 1, and this is valid for t between 0 and 12, where t is the time in months. All right, so 1, what was the average score on the original exam? All right, so the original exam means that t is equal to 0. All right, so you get 75 minus 6 ln, and 0 plus 1 is just 1. All right, ln of 1 is 0, so this just equals 75. All right. What was the average score at the end of 2 months and 6 months? We can just kind of do those together. All right, so 2, t equals 2, 3, t equals 6. So here we get 75 minus 6 ln of 2 plus 1, that will be 3. And here, 75 minus 6 ln of 6 plus 1, that would be 7. So we can go ahead and plug these into our calculator. So after 2 months, the average score would be 68.4. And after 6 months, the average score would be 63.3. So we'll just say 68 and 63. All right, so obviously, once you learn something, the longer you go without using it or without continuing to study it, right, obviously your grades will continuously drop. All right. This was obviously very quick. Of course, you'll have an assignment on Delta Math, but I'll probably be posting another video as well today.